This is class 12th Indefinite Integrals Mathematics of R.d. Sharma. We are taking the solutions of exercise 19.25. Now this x square cos x dx. Now there are two separate functions, x square and cos x. We normally take x square as the first function. I'm not saying always. You'll see where it will not be taken, but 99% of time we take the first as the x square, which is the algebraic function. Second, we take it as the cos x or whatever is remaining. There are certain things which are going to come in this solution, so we need to intimate you prior. So the integration of cos x is going to be sin x, and the integration of a sin x is going to be negative cos x. So we'll take the formula by now. I hope you are well versed with the formula, so I'm directly using it. The first function outside, then the integration of cos x with dx, then the differentiation of the first function, which is d by dx of x square, and multiplied by the integration of the second function, which we already done, or which will be done already in the first term, and then whole of them, these two will be multiplied, and then the integration will be done. So x square here, integration of cos x will be sin x. We are utilizing this earlier intimation, and d by dx of x square will be 2x. Integration of cos x is going to be sin x. So if you take these two outside, we are left with integration of x sin x. Integration of x sin x, we are going to deal it in a separate way, and then we will put this result in the actual solution. So we are integrating it again in the same manner of u and v. Again we are having an x, that is the algebraic expression. Sin x is v. So x integration of sin x minus integration of d by dx of x and integration of sin x, and this whole result with a dx. X, what is the integration of sin x? It's negative cos x. What is the differentiation of x? It's 1. What is the integration of sin x? It's going to be negative cos x. That are already being done. So this will become positive integration of cos x. Integration of cos x is also known to us, which is directly sin x. So negative cos x plus sin x is what we get here. But there is a negative 2 outside, so just multiply negative 2 inside with negative x cos x plus sin x and write the result with x square sin x. So if you multiply this negative 2 inside, it's going to be plus twice of x cos x, and then negative 2 inside, so it will be negative 2 sin x plus a constant of integration. That's your final result. Now this is how you have to go about it. You have to write it like this. Now this x square cos x, as I intimated you earlier, it is going to come again, same question. So x square cos 2x is the same question which we have just completed, but it has a cos 2x angle in it. So need an explanation for that. X square we will take it as the first function, cos 2x will take it as second function. X square integration of cos 2x, that's the formula I am employing, and integration of d by dx of x square, which is our algebraic expression. Then the integration of cos 2x, and these two will be multiplied, and final will be integrated. So here you have x square cos 2x has a direct integration, which is sin 2x, and you have to differentiate 2x, which is 2, and you have to divide it. So 2 comes in the denominator, minus integration. Now this sin 2x by 2 has already been is the result of the integration of cos 2x, so you don't have to integrate it again. So just write sin 2x by 2 in place of integration of cos 2x, which was earlier being done. X square differentiation is 2x, so this is a separate entity now. 2 gets cancelled. You have to integrate x sin 2x separately. So x sin 2x we are going to integrate again, and in the same way u and v form first function, second function. Let me write this x square by 2. This is the first term which is already the first part of the answer. The second part we have to integrate again. So we have x as sin 2x. X come in front, sin 2x here, minus integration of what? D by dx of x, and the integration of sin 2x again. And once integration of sin 2x has been done, multiplied by d by dx of x, that has to be integrated. What is the integration of sin 2x? It's minus cos 2x divided by 2, because minus cos 2x is the integration of sin 2x, but 2 has to be divided because it is the differentiation of 2x. Now again cos 2x by 2 here, you have to add a negative also. And d by dx of x is 1. So you can take this half common, minus cos 2x, and since minus is there, we have made it already as a plus. So this cos 2x direct integration will be sin 2x by 2. So you have sin 2x by 2 here, and you have a 2 already in the denominator. So this will form sin 2x divided by 2 into 2, that is 4. Now negative is there, just change the sign and write this term which we have just found. So x cos 2x divided by 2, and since negative is outside, the sign will get changed. It will be sin 2x by 4 plus constant of integration. That's your final result. Okay. Now how you are going to write it, this is in front of you. That reference is very important. So this x sin x has already been completed. We have already done it, but this is x sin 2x. So we need to formulate a proper approach to solve this question, so that because this is going to become x sin 2x, you will just see x sin 2x will come again and again. First we will take the algebraic expression as the first function, call it as u. The second function we are calling it as v. So I am employing the formula x integration of sin 2x minus integration of d by dx of x, which is the first function, and the integration of sin 2x again, and then the multiplication of these two terms. When you multiply these two terms, that has to be integrated again. Integration of sin 2x is what? Because twice we have to do it. Integration of sin 2x is negative cos 2x divided by 2. So let me replace negative cos 2x divided by 2 wherever we get integration of sin 2x. So negative cos 2x by 2 minus d by dx of x is 1. And integration of sin 2x is negative cos 2x by 2. So negative comes in front. It will make this negative as positive. This half I am taking outside. It will be cos 2x inside. And cos 2x also has a direct integration. So we have minus x cos 2x divided by 2. Cos 2x will give you what? It will give you sin 2x divided by 2. And since we already have a 2 in front, 2 gets multiplied in the denominator and form as 4. So sin 2x divided by 4 plus constant of integration is your final result. This is how you are going to go about it. This is the reference which I wanted to show you. It's a simple question, but it will be employed a lot. Now log x divided by x, this is a different kind of question, because you need to understand that the differentiation of log x is 1 by x. So differentiation of log x is 1 by x, that we have to employ, and 1 by x is what? 1 by x, so log x has to be taken u. I told you 1 by x is an algebraic expression. 1 by x will form x to the power minus 1. But you don't take it always as the first function. Here log x has to be taken as the first function, and then the second function as integration of 1 by x, because we know the integration of 1 by x directly. So we will not fall into any trouble. So log of log x, then we have the integration of 1 by x dx minus integration, and then the differentiation of log x. Always write log x as log bracket x, because these are all separate entities. So d by dx of log x we have to do first thing. So let me write it again in order to tell you that you have to write exactly like this. You have to make brackets. You cannot just write log x in a free form. It has to be bounded inside your brackets. Then the integration of 1 by x, multiply these two terms and you will get a dx. So log x, 1 by x has a direct integration result. What is it? It's log x. So these all are different. Log of log x is a separate term, and log x which we just got is a separate term. So just bound them inside your bracket so that the examiner feels well. 1 by x integration is log x. Log x differentiation is 1 by log x, because anything inside log will be 1 by that thing. So 1 by log x. Now log x has to be differentiated again, and that will give you 1 by x. So what do you get? Log x gets cancelled. You have 1 by x integration, and 1 by x integration already we know. We have just done it. It's log x. So the final answer will be log of log x, that's a separate term, multiplied by log x, that is along with the first term. Let me put it in front so it will be better, log x. And then this term minus log x, 1 by x integration is log x only. So minus log x plus a constant of integration. That's your final result. So this question seems to be easy, but once you do it, you will see that there are so many things which are involved in this question, which I tried to explain to a certain level. X square cos x, as I told you, this question is going to come again. So just have a reference again and try it yourself so that you are well versed with this kind of solution. X cosec square x. First of all, we know that cosec square x integration is available to us. X is an algebraic expression. Normally we take this x as the first term. So x we are taking it as ux integration of cosec square x dx. I am employing the formula now. And the d by dx of the first term, which is x. So d by dx of x is this one. And then integration of cosec square x. Now this is your result, but these two terms have to be multiplied and then again integrated. Cosec square x has a direct integration which is minus cot x. So just write minus cot x here. Minus x cot x. Now minus cot x, just write it here, minus cot x. D by dx will be 1. So you have to integrate negative cot x, but I will prefer to take negative outside. So I have made it as positive. Integration of cot x has a direct integration, which is log sin x in the modulus sign. So log modulus sin x is the direct integration of cot x. That's why I have written it directly. Plus constant of integration. So how you are going to go about it, that has a very special reference here. This question is quite easy, but there are certain integration differentiation result which you ought to know. Now we have x cos square x dx. Now this is a very good question because x sin square x, all these questions are going to be coming in a short while. X cos square x, if you take x as the first term, integration of cos square x will be a problem. That is, I always tell you that try to take this x as the first or the algebraic expression as the first function. But when you integrate it as cos square x, then we will fall into trouble. So we have to either know the integration of cos square x, or we need to convert this cos square x into certain form where the integration is possible. We have an expression of 2 cos square x which is equal to 1 plus cos 2x. Or normally we generally say that cos square x is equal to 1 plus cos 2x by 2 and sin square x is equal to 1 minus cos 2x by 2, that you already know from the trigonometry back knowledge. So cos square x can be written as 1 plus cos 2x by 2. Now take x as the first term. Integration of now this 1 cos square x has to be replaced by 1 plus cos 2x divided by 2 and minus integration of d by dx of the first term, which is x. So I am doing the differentiation of the first term and then the integration of the 1 plus cos 2x divided by 2, and this whole result, when you multiply these two results, then it has to be integrated again. So we'll do it in a separate way. 1 plus cos 2x by 2 has to be used in 2 points, so integrated. 1 by 2 you can take outside. 1 plus cos 2x is remaining. So it will be just x inside. So first integration will be of x. Let me just do it clearly now. 1 plus cos 2x we have to integrate. 1 by 2 is already outside. So integration of 1 has to be done and integration of cos 2x has to be done. Integration of 1 is what? It's dx only. Dx. 1 into dx. Integration of cos 2x has to be done. Half is already outside. Dx is simply x. Cos 2x you already know. We have been doing it for a while now. It's sin 2x divided by 2. Since we have a half outside, we'll multiply it inside. So that will give you, let me write it here because this has to be placed in 2 places. So x by 2, x plus sin 2x by 2 minus. Now d by dx will be 1. Half you can take outside because ultimately you have to write this x plus sin 2x by 2 result. So we have x plus sin 2x divided by 2 and this has to be integrated again. So let's do it separately and then we will multiply it later by half. What is the integration of x? It is x square by 2. What is the integration of sin 2x? It will be minus cos 2x. And then we have to differentiate 2x. That will be 2. So it will come in the denominator. So 2 into 2. Half is already there outside. So multiply it inside. So minus this will be negative. This will be positive and replace it as it is. X square by 4 it will be negative x square by 4. And half I have multiplied it already. Half was already there. So 2 into 2 into 2 that will form as 8. So cos 2x divided by this will be 8. And this will be multiplied inside. X into x will be x square by 2. And x by 2 into sin 2x by 2 will be what? It will be x sin 2x divided by 4. So it will be, there is a 4. Okay, I just missed it. But we will write this x square by 2 minus x square by 4 as x square by 2. Because you know if you take x square common, it will be simply 1 by 2 minus 1 by 4. 1 by 4 is half of half. So you are taking out 1 by 4 from 1 by 2, that will form 1 by 4 only. So x square by 4 and all other things will remain same. X sin 2x by 4 I'm not writing it as 2 cos 2x by 8 plus constant of integration. Okay, there is a slight change. You can do it by yourself. This is your result and this is how you are going to write it. Alright, so I tried to explain you in a detail, but the way you are going to write it is right in front of you. This question will be taking in the next discussion. Till then, thank you so much and have a good one.